title of this presentation is Computer Approaches in Physics Learning and its Merit and Design. The second point, first of all, you have to gain the energy, the confidence when you come here, right? So initially, if your mental formation or configuration somehow disturbed, then you cannot get the actual energy, which is basically based on the language, right? Based on the audience. So these are two important things: your language, command on the language, and the audience who are sitting in front to you, right? Like the second point comes about the language. Are we confident that the way which we are using in terms of the language are able to communicate with you? If we are confident on that point, then we have to proceed further. So right now, the title is the Computer Approaches in Physics Learning, its Merit and Demerits. Right? This is the title. Here my purpose is just to show that how one can integrate all the teaching tools in our classroom teaching. This is the point. Right? So the content of this presentation includes introduction, analogy of the physical concept, past present classroom situations, teaching tools which we use here like board, laptop, our personal computer, projector, simulations, internet, sound system, and some technical software. Then we will discuss about the applications and at last summary of this presentation. So as you know that many of the great teachers always follow the analogy. Analogy means a correlation of the physical concept with the real object. But right now we are playing with the technology, and the technology provides exact physical picture. There is no need to give analogy of any physical concept. This is the idea behind of this presentation. The old time for the best teachers, and right time now at right time, this time the availability of the technology. So this represents life. My main concern is about the undergraduate and postgraduate students, those who are dedicated to the sciences, being a part of our community, what and how they are learning about the science. And there are no authentic technical resources except to the NPTEL videos for undergraduate and postgraduate students of that level, as we see for the students of up to +2 and for the research degree. You know that up to the +2 levels, all the technical facilities are available in terms of multimedia. You have animated digital courses, you have PowerPoint presentation, you have demonstration also for the students. And similar, the technical advanced technology we have for the research student also. But there is a big gap for the undergraduate and postgraduate students. There we are lacking, and my concern is about those students. How one can basically provide the technology to those students in terms of the real physical picture, in terms of the real science, where we are not basically providing the analogy to those students. Those students is still following the local author textbook. Right now, we are in advanced technology, we are playing with the advanced technology, but those students are playing with the local author books. Those are basically parts of our community, so we have to think about those. We have to provide the latest technology to them. So these students are not exposed up to that extent in sciences at which they should be. So my efforts and all the activities are basically focused on that. But the point basically, it gives the motivation to me in this particular direction for all these activities. My desire to use the latest technology in terms terms of the education, my passion for utilization of technical teaching tools, and at last my commitment for the undergraduate and postgraduate students to fulfill the technology gap. These are the points which basically motivate me to do something for those students. Now I am giving the successively example of that methodology which we use into the classroom. The first one is analogy, which the best teacher use in the classes. So I have just taken a simple example of the atom. You know that if we have a circular building of the institute or school or college, then we can compare the atomic structure with that. A cell corresponds to the floor of the building, room equivalent to the orbitals, number of students of a particular section, the number of electrons in a particular orbital. Right. So this is one of kind analogy. This picture basically indicates to the ground state of the atom. Right. These three people, friends, watching the TV, and they are just enjoying their life in a normal mood. There is no excitement. The internal configuration, right now we can compare with ourselves. We are in a ground state. There is no change in our internal configuration. But somehow they see something different. And then what happens? The internal configuration changes. Internal configuration of the mind changes. They cry, they enjoy, full enjoy of their life at the moment, of that moment particularly. So what happens? This is second kind of analogy. So how you basically gives the example of the physical concept with the daily life. This is idea of that. Now, in reality, we know that excited state and ground state of the atom we define with the help of the electronic configuration. In this reference, everyone knows that we give this kind of definition. When electron absorb the energy in an atom, I have specified here it. It means not electron, atom, goes into the excited state. And then I am asking about that this statement is true or false. Every science person knows about it, that electron absorbs the energy and atom goes into the excited state. Every book local to the standard use this goes word. And how the student basically thinks about that physical concept. But before that, my question is to you, all of you, that this statement is true or false? Yeah? True or false? This is true? True. Everyone have to say true or false. This is the involvement of the audience.
True, true.
This is true. Atom displays from one position to the other. The students think in this way, that one atom absorbs the energy and goes into the excited state. It means the visualization of the student is in this form. They think that atom absorbs the energy and goes here. And in a similar way, the next definition which we gives to them with the help of these two lines that indicate to the E naught indicate to the ground state of the atom and E1 indicate the excited state of the atom. Everybody knows and everyone use it. But what the students think? Students think that there is a gap, there is a gap space in between these two lines. But actually the person knows that this is just only the representation of the ground state of the atom, and second line is representation of the excited state. There is no physical gap in between these two lines. And how the students think that when we provide this, that this photon comes by this way. The students think that this photon physically comes in between these two physical situations like this. So here, because of that, academician says that what we are teaching and what they are learning, because of this point. Actually, what is in our mind, are we able to communicate exactly with that physical picture with the students? These are some basic examples which I have considered here. Now the second example of oscillation and vibrations. Again an analogy. Sometimes analogy can mislead the concept. This is true that good teacher give the example, but many times it might be that we ourselves can mislead the concept of that science. Earlier, the classroom situation. Earlier, teacher was a facilitator. Now, the teacher is an instructor. This is the difference of classroom. Here, you can see that this teacher take the round in classroom, observe the students, what they are doing. Here, at the present time, you can see teacher is standing near to the whiteboard. The students are sitting near to their machine. What they are doing, they just give the instruction that you have to do this way. They are not facilitator. They are not providing the solution of difficulty. They just give the instruction. Right now, we have just changed the color of the board. Earlier it was black and now it is white. The second tool is projector. Earlier it was projector, right? And now we are playing with the smart boards or the digital projector. Major visual teaching tools in classroom. What are those? Number one, black and white boards. You cannot ignore the most important teaching tools in the classroom. Whether you are playing with any advanced technology, but you cannot ignore this one. Second point is the PowerPoint presentation. Third tool is the graphics tablet and digital pen. Videos, simulations, these are mainly main important teaching tools which we use in our classroom. There are some demerits of each teaching tools. Only whiteboard or blackboard is not sufficient to express that concept which we want to communicate with the students. That have some limitations, right? Similarly, slideshow, PowerPoint presentation have limitations also. When you present only with the slides, you have observed many times that students or any audience, whether the students or we are sitting there, we lose our interest there. Right? Now, this is an example of a PowerPoint presentation. Your PowerPoint presentation is static or dynamic. Here I just consider an example of PN junction diode and to define with the help of it the energy band. Everybody knows that this is N and P type semiconductor. Majority, I am not going into the detail that what is the effect, but I am just trying to show that the dynamics into the PowerPoint presentation by using the animation. Fusion, diffusion. By this way, one student can realize the actual physical picture with the help of PowerPoint presentation and the animation which we use into that. Now you can see the depletion region. So at last, the minority charge carrier basically playing the role. But this is not point to teach the physics here. Point is only the concept that which we are using in our PowerPoint presentation. Is that static or that dynamic? So here the same concept we are using for the energy band. Here we say that electron cannot cross the junction, but with the help of this simple PowerPoint presentation we can show it. That why this electron cannot cross the junction. Both the ideas are placed together in a PowerPoint presentation. Because we use the word barrier, how the student visualize that barrier. In reality, the concept, physical picture which we are providing to them. Right, so this was just only the dynamics into the PowerPoint presentation from that point of view, and this is also same, and now the graphics tablet. What is the difference between the PowerPoint presentation and the whiteboard or blackboard? Now the graphics tablet basically have included both the concept. Now this have integrated both the things. Now I can use my marker or this, whatever I want to write, I can write. So here I am just displaying using the PowerPoint presentation, but I can use my whiteboard also. So I have integrated both the concept. So integration of the technology is important. Now a student cannot lose their interest into the classroom or anywhere, any audience, because now you have integrated the technology. Right, so this is the point. Now I have just tried to show this example by using, and the fourth point comes that now we have seen three tools. One was the blackboard, whiteboard, second was about the PowerPoint presentation, third is this graphics tablet, and now comes to the point on the simulation sources. In PowerPoint presentation we have some limitations. We can just show the animation into the physical pictures, but we cannot change the variables of that physical concept. With the help of simulation, one can demonstrate the physical picture in actual form by changing the variables into that, and here simulation plays the role. So this is one of the example which I am using here. Why the simulation? Everybody knows that this is y-axis, z-axis and x-axis. Here this represents that the electromagnetic waves in which electric field component is propagating along the x direction. Vibrations of the field along, we are not sure that along the z-axis or y-axis. Let us try. With the help of this button, you can move it. Right? And this one. You can take y-axis, z-axis properly. Now, you have seen that electric field component is along the z direction. Second point comes about these variables which are given here. If I use the second one, magnetic field component here, then the picture visualized like this one. But why they have given this Ey and Ez? Why not Ex? If I use this Ez, this is from physics point of view, but the contribution of this component plays the role. How that playing the role? We can show it with the help of simulation. By changing the position, delta, if we are able to introduce the phase, then the appearance of that wave and the wavelength and the time. So you can see it here in motion, that when electromagnetic wave travels. So for that we have to modify it in actual form. So this is just a simple example of simulation, right? And many other examples are available here. This is in HTML. You can see that if I have to show a magnetic field lines, I can click here. By this way, when the magnetic flux basically change associated with the coils, you can see the behavior of voltage. Right? You can also change the polarity of the magnet. In that sense, that you observe any change? So these are just simple examples of the simulation by which we can integrate all these in our teaching. Then we can provide the exact physical picture of the concept. This was the only point. And further, these are the sources from I have taken. Energy plant simulation is available, but I am not interested right now to show that. But everything is available here. Video demonstration with the help of this physics, open source physics. These were some example, and the situation with the help of PowerPoint presentation, that these are the physical facts, these are the theory, and now this is the point of simulation. The second hyperphysics is the website from which you can conclude some result only, and here the role of mathematics into the physics. Just by taking a simple example of it, I will try to show you that you can see the electric field of the positive charge. This is a closed surface, open surface, closed surface, negative charge. Electric field you can see everywhere here, and this is the closed surface. Now, how the mathematics basically play the role in physical concept. When you are using closed surface integral of any physical quantity, what is it means? When you are using the open surface integral, what is it means? And similarly, you can see here that divergence is positive, 0 and negative. We use these words in class that divergence is 0, positive or negative. But what is the physical picture of that? Or how similarly, this is vice versa. Mathematics is a tool to explain the physical concept. Mathematics is the language of physics. Right? And with the help of physical pictures, one can show the use of that mathematics. So this is a simple example. And now the YouTube channel, blogs also can help us in terms of making the concept right in actual form, and in last the summary. That summary basically is based on the simulation mainly. Develop their understanding, simulation develop their understanding about the phenomena and physical laws through a process of hypothesis, making the idea exact. And one can test also that in terms of conceptual form, what he learned, is he or she able to implement that theoretical concept into the real world? This is the role of simulation. Right? So, this exciting new phase of my teaching practice into the classroom. I have integrated all the technology, and because of that, I have found really something different. From your side, any tips, suggestion which you want to share, you can share. And also your experience with the technology in the classroom. In addition to this, I want to show a small movie.
Teachers, businesses, and nonprofit organizations take big new steps to support computer science in American schools. Learning these skills isn't just important for your future, it's important for our country's future. If we want Americans to stay on the cutting edge, we need young Americans like you to master the tools and technology that will change the way we do just about everything. That's why I'm asking you to get involved. Don't just buy a new video game, make one. Don't just download the latest app, help design it. Don't just play it on your phone, program it. No one's born a computer scientist, but with a little hard work and some math and science, just about anyone can become one. This week is your chance to give it a shot. And don't let anyone tell you you can't. Whether you're a young man or a young woman, whether you live in a city